You know, there's this invisible tug-of-war happening all around us, all the time. It's in the food we eat, the products we use, even in the soil under our feet. It's a really fundamental part of chemistry, the chemistry of opposites. We're talking about acids and bases. So let's dive in and see what that's all about.
Okay, let's start off with a little puzzle. What could lemons, a bar of soap, and an antacid tablet possibly have in common? I mean, they seem totally unrelated, right? Well, chemically speaking, they are all part of the exact same story.
And the answer to that puzzle? Well, it's that they are all fantastic examples of acids and bases, these chemical compounds that are, and I mean this literally, everywhere.
So first up, let's talk about acids. The easiest way to think about them is to picture biting into a lemon. That sharp, sour, puckering taste, that's a classic sign of an acid. Of course, in more concentrated forms, that sourness becomes something much more powerful, a really corrosive property.
Now, on the complete other side of the spectrum, we've got bases, and you definitely do not want to taste these. Their telltale sign is a slippery, almost soapy feel when you mix them with water. And just like their opposites, strong bases can be incredibly corrosive too.
So with these two powerful opposites, how can we tell them apart safely? Well, chemists came up with a really simple but honestly brilliant solution for this: the litmus test.
The litmus test is the classic for a reason. It's just so simple and clear. If you dip blue litmus paper into a substance and it turns red, you've got an acid. If you dip red litmus paper in and it turns blue, you've got a base. It's a quick, visual way to get an answer.
And that's the power of what we call an indicator. Think of litmus paper as a kind of chemical detective. It doesn't need a lot of fuss. It just reveals the secret identity of a substance with one simple change of color. It's an amazing little tool.
Okay, but just knowing if something is an acid or a base isn't always enough. Sometimes we need to know how strong it is. And for that, we need a different tool entirely. We need the pH scale. So, right, how do we actually put a number on that strength? Chemists needed a standardized way to do this, and what they came up with is both simple and incredibly powerful.
It all starts with one number, 7. You've got to remember this one. 7 represents perfect neutrality. It's not an acid, and it's not a base. The best example? Pure water. And once you know that 7 is neutral, the rest of the scale is super easy. Anything with a pH less than 7 is acidic. The lower the number, the stronger the acid. And anything with a pH greater than 7 is a base, or alkaline. The higher the number, the stronger the base. It's this perfect chemical spectrum from 0 all the way to 14.
Okay, now we get to the really cool part. What happens when these opposites actually meet? This is where the real chemical magic happens. It's not just a tug of war, it's a head-on collision.
The process is called neutralization, and it's exactly what it sounds like. It's this amazing chemical reaction where an acid and a base go head-to-head, and they essentially cancel each other out. Their properties just disappear, and they create something totally new.
The basic formula for this is just beautiful. You take an acid, you add a base, and what do you get? A salt and water. That's it. Two potentially very reactive substances combine to create something that's usually completely harmless.
And trust me, this is not just something that happens in a lab. It is happening all around you. That antacid tablet you take for indigestion, that's just a mild base designed to neutralize the extra acid in your stomach. When farmers add lime to their fields, they're using a base to correct soil that's gotten too acidic. Even something as simple as putting vinegar on a wasp sting is an example of a mild acid neutralizing an alkaline sting. It's chemistry in real life.
So this whole idea of neutralization is way more than just a neat chemical trick. It's actually a supercritical tool that's used all the time in science and in industry.
In fact, scientists have figured out how to harness this perfect balancing act in a technique called titration. It basically turns neutralization into a precision measurement tool.
Here's how it works in a nutshell. You start with an acid, but you don't know its strength. Then you very carefully add a base that you do know the strength of, drop by tiny drop. You also add an indicator, which will change color at the exact moment that neutralization is complete. By measuring exactly how much base you needed to add, you can calculate the precise strength of the original acid. It's pretty genius.
So, from the acid in your stomach to the soil in a field, this incredible balancing act between acids and bases is constantly shaping the world around us. Now that you know what to look for, where else can you spot this invisible chemistry in action?